Hello and welcome to our Geomagic Control X and Artec Micro collaboration. The purpose of this demonstration is to show up quickly and easily validate a part or a manufacturing process by comparing 3D scan data to a Referenz-CAD model. An overview of what this demonstration consists of is we will import data, do an initial alignment which roughly aligns the measured data to the reference data. Then we will do a more refined alignment using a best fit condition. Once aligned, we can now use our compare tools such as 3D compare, comparison points, and 2D compare, which shows profile deviation between the measured data and the CAD data with a set deviation. This is a great tool for first article inspection to assure that the manufacturing process is correct. Then we will get into dimensioning the part and also utilizing our GD&T functionality. Once the critical dimensions are made, we will generate a report. First, we will open a new Control X workspace. Let's import the Artec Micro Start CX project file. Once open, you'll see that the measured data is not aligned to the CAD data. To get a rough alignment, let's use the Initial Alignment tool and click the check mark. The Initial Alignment tool recognizes similar features on both the reference and measured data to perform a quick best fit alignment. Now that we are roughly aligned, let's use the Best Fit Alignment tool, which aligns the measured data to the reference data using overlapping regions between them. Best Fit aligns measured data to minimize deviation in the overall shape. Click the check mark to accept. Now that our data has been aligned to a best fit condition, let's use the 3D compare tool to analyze the deviation between the reference and measured data by projecting all paired points or polygons onto the reference data. The deviation is displayed with a color map, often referred to as a heat map, which helps visualize negative and positive deviation across the entire part. Open the 3D compare tool in the Compare tab. Under Projection Direction, click Along Normal and click Next Stage. Under Display Options, check the Color Map and Show Contour Lines. Change the specific tolerance from plus or minus 1.1 to plus or minus 0.25. Next, turn on the local averaging tagging by clicking the box next to the over tolerance and under tolerance count. Click the checkbox to accept. For reporting purpose, orient the part in the way that best depicts critical information. Highlight 3D Compare in the Model Manager. In the Result Navigator, hit the Reassign Viewpoint button. And this view will now be generated in the final report. Now let's use the Comparison Point tool. This will let us highlight critical deviation zones between the reference and measured data at specific points. Comparison points are established on the reference data, which allows them to be repeated. Open the Comparison Point tool in the Compare tab. Under Methods, select Pick Points. Under Color Bar Options, change the specific tolerance from plus or minus 0.1 to plus or minus 0.25. Zoom in to a critical position on the part that is showing deviation and click some of the critical high and low positions. Check Accept. Like 3D Compare, orient the part in a way that best depicts critical information. Highlight CMP1 in the Model Manager, and then in the Result Navigator, hit Reassign Viewpoint, and this will be generated in the final report. Now let's use the 2D Compare tool to analyze the deviation between the Referenz-CAD and measured data on a 2D section profile. The 2D Compare provides a similar visual to a 2D drawing. Open the 2D Compare tool in the Compare tab. Under Set Section Plane, select Offset and choose Plane Y as the base plane. Change the offset distance to 12 mm and hit the reverse direction. Click the Next Stage arrow. In the next stage, keep specific tolerance at plus or minus 0.1. Turn on the local averaging tag by checking the boxes next to over and under tolerance count. Click the checkbox to accept. Note if there are no over or under tags, the part does not deviate from the reference in that direction. Now it is time for the geometric dimensioning tools to analyze dimensions on critical features. Click on the Dimensions ribbon, highlight the 3D GD&T, then click Add Group. Click on the Smart Dimension tool. Note the Smart Dimension tool is a single tool that combines the 4 standard dimension types into a single tool. Each dimension is automatically determined by the combination of selected target entities. Measure the width of the 3 mounting tabs. Click on the tab's outside plane. Click on the second tab's outside plane for overall length and change the tolerance from plus or minus 0.1 to plus or minus 0.25. Now measure the remaining linear dimensions for the tabs by continuing to click the CAD planes. Change the tolerance from plus or minus 0.1 to plus or minus 0.25. Measure the radial dimensions. Click on the main CAD cylinder for a radial dimension. Change the tolerance to plus or minus 0.25 and measure the remaining cylinders. Note the Smart Dimension tool allows creation of multiple dimensions of varying type without exiting the tool or manually accepting each dimension. To have a more detailed annotation shown for the dimensions, right mouse button click on the annotation, click on Preset, and click on Detailed. Annotations can be customized by right-clicking on an annotation. You can choose from a list of preset styles, or you can choose Edit Annotation Style and customize the annotation. You have the option to do this for one tag at a time, for a group of annotations, or for just a specific type of annotation. For more individual dimensions, left mouse button click on a specific dimension type. Use the same as Smart Selection. For reporting purposes, orient the part in a way that best depicts critical information. Highlight 3D GD&T in the Model Manager, and in the Result Navigator hit the Reassign Viewpoint, and this will now be generated in the final report. Now let's go through a few GD&T callouts to analyze critical features which will need to interact with other components in a specific way. Open the Dimensions tab, highlight 3D GD&T, click Add Group. There should be a Group 2 under 3D GD&T now. Let's perform a parallelism measurement. A datum must first be established which the feature will be measured against. Click on the datum in the Geometric Tolerancing tab and select the CAD plane to establish datum A. Click the check to accept and open up the parallelism tool. Select the middle CAD plane, change the tolerance to plus or minus 0.25 and select datum A in the drop-down. And click check to accept. Now let's establish a concentricity callout. Click on the Datum tab and select the CAD cylinder to establish datum B. Open the Concentricity tab. Select the middle CAD cylinder. Change the tolerance to plus or minus 0.25 and check Show Fitting Deviation. Click on the check to accept. And once again, for reporting purposes, orient the part in a way that best depicts critical information. Highlight 3D GD&T in Group 2 in the Model Manager, and in the Result Navigator hit the Reassign Viewpoint, and this will now be generated in the final report. We can now move on to the cross-section tool to create 2D sections from the reference and measured data. The cross-section tool generates 2D section drawings similar to 2D drawings in most CAD packages. In the 2D section view, you can inspect features using the 2D GD&T tools. Open the Dimensions tab, highlight 2D GD&T, click Add Section, select Plane Y, and enter 12 mm offset. Use the Reverse Direction button, and click the check mark to accept. Open the Smart Dimensions tool, and select the 2 CAD lines for a linear dimension. Keep the tolerance at plus or minus 0.1. Now you can select additional CAD lines to make more dimensions. Click the check button to accept. Now it's time to generate a report. By default, everything you inspect will be included in the list of selected entities. You can add or remove inspection entities for the report by selecting the item and then clicking the left or right arrows to move it in or out of the list. You can also prioritize entities using the up and down arrows in the dialog box. Open Generate Report, highlight Initial Alignment, and use the arrow pointing left to remove it from selected entities. Click on the 3D PDF page and add Artec Demo Kit in the title bar, and click Generate. This concludes our Geomagic demonstration. We at Geomagic like to offer benchmarks for the customer to allow them to get excited about all Control X has to offer. Please reach out to us at Geomagic if you have any questions. Thank you very much.